Dear students, welcome to the today's chemistry class. We are discussing chemical bonding and molecular structure. In the last class we discussed formal charge and limitations of octet rule. So in this class let us discuss lattice, enthalpy, lattice enthalpy. So lattice is nothing but a structure, crystal structure. So enthalpy means energy. So lattice enthalpy is the amount of energy required to completely separate one mole of solid ionic compound into its neutral gaseous constituent ions. So that is amount of energy required to completely separate one mole of solid ionic compound into its neutral gaseous constituent ions. ಅಂದ್ರೆ ಒಂದು ಸಾಲಿಡ್ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಇಂದ ನ್ಯೂಟ್ರಲ್ ಗೇಷಿಯಸ್ ಅಯಾನ್ಸ್ ಆಗಿ ಸಪರೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ನಾವೇನು ಮಾಡಬೇಕು, ಕ್ರಿಸ್ಟಲ್ ಸ್ಟ್ರಕ್ಚರ್ನ ಬ್ರೇಕ್ ಮಾಡಬೇಕು. ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ದಟ್ ಪ್ರೆಸೆಂಟ್ ಬಿಟ್ವೀನ್ ದಿ ಟು ಅಪೋಸಿಟ್ಲಿ ಚಾರ್ಜ್ಡ್ ಅಯಾನ್ಸ್ನ ನಾವು ಬ್ರೇಕ್ ಮಾಡಬೇಕು. ಸೊ ಬ್ರೇಕ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಏನು, ಎನರ್ಜಿ ಇಸ್ ರಿಕ್ವೈರ್ಡ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ lattice enthalpy. So it is the amount of energy, required, to completely separate, to completely separate one mole of solid ionic compound, into its neutral gaseous constituent ions. The amount of energy required to completely separate one mole of solid ionic compound into its neutral gaseous constituent ions is called as lattice enthalpy. Let us take an example. Sodium chloride is one mole of solid ionic compound. In this sodium chloride, Na plus Cl minus ions are electrostatically attracted to form ionic bond. Now, from this sodium chloride, let us break electrostatic force of attraction that present between Na plus and Cl minus to form Na plus gaseous ion plus Cl minus gaseous ion. So to separate one mole of solid ionic sodium chloride compound, we require standard change in lattice enthalpy as plus 788 kilojoule per mole. 788 kilojoule per mole of lattice enthalpy or energy is required to completely separate one mole of solid sodium chloride into neutral gaseous sodium ion and chloride ion. So this is called as lattice enthalpy. Okay, next. Bond parameters. means bond order, bond length, bond enthalpy are called as bond parameters. Bond order, bond enthalpy and bond length, bond angle are called as the bond parameters. Bond parameters. So let us discuss one by one. First one, bond length, bond length, bond length. Bond length is nothing but length of the bond. See, between the two atoms, a single covalent bond or a double covalent bond, so it means double bond or triple bond may exist. So length of the bond, length of that bond present between two atoms is called as bond length. So that bond length, that length of the bond present between two atoms do not vary, so that it is called as a equilibrium distance. The distance or the bond present between two atoms is called as equilibrium distance. So the equilibrium between two bonded atoms in a molecule is called as a bond length. The equilibrium distance between the two bonded atoms in a molecule is called bond length length of the bond. The equilibrium distance between the two bonded atoms in a molecule is called bond length. This bond length of the bond present between the two atoms can be measured by spectroscopic method or X-ray diffraction method or electron diffraction method. So length of the bond generally measured in terms of picometers. Bond length is measured in picometers. Bond length is measured in picometers. Bond length is measured in picometers. 1 picometer is nothing but 10 power minus 12 meter. Bond length is measured in terms of picometers. 1 picometer is nothing but 10 power minus 12 meter. And bond length can be measured by a spectroscopic method, X-ray diffraction method and electron diffraction methods. To define this bond length, we can consider covalent radius and van der Waals radius. So to define this bond length, we can consider covalent radius and van der Waals radius. So covalent radius. Let us consider two covalently bonded atoms in a molecule. So these are two covalently bonded molecules, two covalently bonded atoms in a molecule AB. Now from the center of nucleus of A atom to the center of nucleus B atom is called as what? Bond length. So this is bond length. Bond, covalent bond. belongs to both the atoms A and B. Now half of the bond length is called as covalent radius RC. Now RC is the covalent radius of atom B, and another RC is the covalent radius of another atom A. So that is, now covalent radius can be defined as half of the bond length or half of the distance between the centers of nuclei. Half of the distance between centers of nuclei of two covalently bonded atoms in a molecule. So half of the distance between the centers of nuclei of two similar atoms in a covalently bonded molecule is called as covalent radius. So it is the half of the distance. It is the half of the distance between the centers of nuclei of similar atoms in a molecule is called a covalent radius. Covalent radius can be defined as half of the distance between the centers of nuclei of two similar atoms in a molecules is called as covalent radius. Nuclei of two similar atoms in a molecule. Example in Cl2 molecule, in chlorine molecule, Cl bond Cl Lattice means in Cl bonds here in chlorine molecule, bond length between two chlorine atoms is 198 picometer. Therefore covalent radius of one Cl atom, one chlorine atom is equals to bond length divided by 2. So that is equals to RC is equals to 198. Bond length between two chlorine atoms in Cl2 molecule is 198 divided by 2. So that is 99 picometer. Covalent radius of one chlorine atom is 99 picometer. Okay, next. Van der Waals radius. Van der Waals radius. So Van der Waals radius is nothing but half of the distance between the two similar atoms of different neighboring molecules in a solid is called as Van der Waals radius. So it is the half of the distance between the two similar atoms of different van der Waals radius. So let us take one molecule, covalently bonded molecule AB. So AB1 covalently bonded molecule. Next, so consider another covalently bonded molecule. So CD. Now, so this is half of the distance. So this half of the distance between two covalently bonded atoms of different molecule is called as RV. This is RV. RV means van der Waals radius. Van der Waals radius. In the same molecule, half of the bond or half of the distance between two similar atoms is called as a covalent radius. Half of the distance between two similar atoms of different molecule is called as what? Van der Waals radius. Okay, next. Second bond parameter is bond order. It is the second bond parameter. Bond order. So bond order is nothing but number of bonds present between two atoms in a molecule. Bond order indicates number of bonds present between two atoms in a molecule. So number of bonds present between the two atoms. Number of bonds present between the two atoms in a molecule. Is called bond order. So bond order is nothing but number of bonds present between the two atoms in a molecule. ಅಂದ್ರೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ಎರಡು ಆಟಮ್ ಮಧ್ಯೆ ಸಿಂಗಲ್ ಬಾಂಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಾ, ಡಬಲ್ ಬಾಂಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಾ, ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಾ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಅಥವಾ ಇಂಡಿಕೇಟ್ ಮಾಡೋದು ಬಾಂಡ್ ಆರ್ಡರ್. ಎಕ್ಸಾಂಪಲ್ 1 in H2 molecule bond order is equals to 1. So that is H bond H. Next, bond order in O2 molecule, O double bond O is equals to 2. Next, bond order in N2 molecule, N triple bond N is equals to 3. So in nitrogen molecule, 3 bonds, triple bond exists between two nitrogen atoms. In oxygen molecule, between two oxygen atoms, double bond exists. And in hydrogen molecule, between two hydrogen atoms, one single covalent bond exists. So bond order is the number of bonds present between two atoms in a molecule. And in isoelectronic species, in isoelectronic molecules and ions, the bond order is same. So it means the bond order is identical. The bond order is identical in isoelectronic molecules or isoelectronic ions. ಅಂದ್ರೆ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರತಕ್ಕಂತಹ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಅಥವಾ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರತಕ್ಕಂತಹ ಅಯಾನ್ಸ್ ಅಲ್ಲಿ ಬಾಂಡ್ ಆರ್ಡರ್ ಕೂಡ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಬಾಂಡ್ ಆರ್ಡರ್ ಈಸ್ ಐಡೆಂಟಿಕಲ್ ಇನ್ ಬಾಂಡ್ ಆರ್ಡರ್ Example 1. Fluorine molecule F2 molecule and O2 2 minus ion have O2 2 minus ion have bond order is equals to 1. So means F2 molecule means 18 electrons. In O2 2 minus also 18 electrons. So these two species having same number of electrons, they are called as isoelectronic ion or molecule. They have only one bond between fluorine atoms and oxygens. Next, bond order in N2 CO and NO plus is 3. Bond order in nitrogen molecule, carbon monoxide molecule and NO plus ion is 3 because in nitrogen molecule 14 electrons, in CO molecule also 14 electrons and in NO plus also 14 electrons are present. So they are called as isoelectronic molecules or species. So they have bond order 3. So totally isoelectronic species or isoelectronic ions have identical bond order. Okay, next. Third one, bond angle. Bond angle is nothing but the angle between the orbitals. The angle between the orbitals containing shared pair or bond pair electrons. The angle between the orbitals containing shared pair electrons or bond pair electrons around the central atom in a molecular or complex ion. So, bond angle means angle between the orbitals. Angle between the orbitals containing the shared pair electrons or bond pair electrons around the central atom in a molecular complex ion. So that is the angle between the orbitals. The angles between the orbitals containing shared pair or bond pair electrons around the central atom in a molecule or complex ion. In a molecule or complex ion is called bond angle. The angle between the orbitals containing shared pair or bond pair electrons around the central atom in a molecular complex ion. Example, bond order of HOH. Bond angle means the bond angle of HOH in water molecule is 104.5 degree. Example, if you take water H2O has bent shape, inverted bent shape. Now HOH bond angle in water is 104.5 degree. 2, there are two lone pairs electrons. See, these are bond pair electrons. And once again, this is bond pair orbitals containing bond pair electrons. So these are the lone pair electrons. So structure is bent shape. So in water, the bond angle is 104.5 degree. So totally bond angle means angle between the orbitals containing shared pair or bond pair electrons around the central atom in a complex ion or in a molecule.